Okay, so an unusual trait they're talking about in this one, there's an allele big T for taste, which if you have if you have it, you're able to taste the compound phenylthiocarbamide. And if you're little t, you can't. So big T is yes, you can taste it, and little t is you can't. And so they test a bunch of students. You just put a little drop of this on your tongue, and if you don't taste anything, then you're little t, little t. If you can taste something, then you have the dominant trait, but we don't know if you're big T, or big T, little t. So I'm just going to write the Hardy-Weinberg expression down because it gives us a place to write our other numbers. 2pq plus q squared equals 1. And I don't think I can squeeze the other one in under there and still have room to write. So we'll just do p plus q equals 1 right there. So what do they give us? In a genetics class of 125 students, 88 students can taste PTC and 37 can't. Well, the 88 out of 125 is good to know. The trouble is, people who can taste it are split up between these two groups, and I don't know how. I don't know how many of them fall into each of these categories. So it's really not very helpful to know the people with the dominant trait. You don't know how to allocate them between these two categories. But if 88 of the students can taste this, then 125 minus 88 tells us 37 students can, and they helpfully give us that number also. The students who can't get it are q squared, and they're the ones we're going to focus on. You remember when we were doing pedigree charts, we were always happy to see people with the recessive allele because we knew exactly what their genotype was. We know they're little t, little t. Well, those people are still pure gold in this section because we know that they're definitely in this genetic category. So, like before, go after the recessives whenever you can. 37 out of 125 is our q squared. 37 out of 125, and let's get out of fraction mode as quick as we can. 37 divided by 125, whoops, keyed that wrong the first try, is 0. I can't be right. 37 divided by 125, 0.296. In other words, 29.6% of our group is unable to taste phenylthiocarbamide. That number is q squared. And the first thing they ask for is what are the frequencies of the two alleles, meaning what are P and Q, right? Because we're talking about people in this formula, and the one they want is the one about just alleles. Well, if Q squared is 0.296, I don't want Q squared, I want just Q, so I can square root this to unsquare it, as long as I do the same thing to the right-hand side. And that results in Q equals 0.544. It's 0.5440582. They only want it to one decimal place, so technically 0.5, but I'm going to keep a few extra for now because I don't want to round prematurely and screw up my answers for parts B and C. So for now, I'm going to stick with this for Q. And P is 1 minus Q, which should be 0.456. So those are the answers, which you'll want to round before you turn them in. Then what do they want? What would you expect to be the heterozygous frequency for the tasting gene? This is the heterozygous group right here, the 2PQ. We can find that easy enough now that we know our alleles. 2PQ. This is people who have the heterozygous trait, so one big T, one little t. It's going to be 2 times P is 0.456 and Q is 0.544. So when we multiply that out, 2 times 0.456 times 0.544, we get 0.496. So just under half, 49.6% of the class would be in the heterozygous category. And then they say, what would you expect to be the homozygous dominant frequency? Well, homodominant is the p-squared group. These are the ones who have the dominant allele twice. P squared is 0.456 squared, which is, calculator, 0.20. I get 0.207936, but just to keep it 3 decimal places like everything else I've done, I'm going to say 0.208. So they gave us q squared. That's 0.296. 2pq is 0.496, and the p squared, the homozygous dominant, is 0.208. They didn't ask for it, but if we add the 3 of these up, q squared and 2pq and p squared, the total should be 1. Let's see if that actually works. If all this sorcery is correct, then 0.208 plus 0.496 plus 0.296 comes out to, dramatic pause while I punch the calculator, and maybe you do too, plus 0.296 comes out to, gorgeous, exactly 1. Sometimes you get a bit of round off error, and when you add these up, you get like 0.999 or 1.001 or something that's very close to 1, but not exactly. If that happens, it's almost certainly just that you had some bad luck with rounding, and if you carried a few more decimal places, you would get exactly 1. If you add these up and you get 49, then something's gone horribly wrong and you should backtrack. But in this case, we crushed it, got exactly 1, so that's nice to see. All right, so get your alleles P and Q, and after that you can knock off any of these groups that they want. The double recessives, the double dominants, the heterozygous, or any combination of them.